You need some way to react to layout changes so you can modify the layout in your application. The template we use for building projects includes code to handle layout. The layout-aware page.cs provides the code. And remember, you won't get that if you just add a blank page to your project. You need to add a basic page. When you do that, you'll get extra classes added to your project, which include layout-aware page.cs. The code in the template maps the current app state to visual states that you define in the XAML. That's hard to understand till we take a moment and just look at the sample. So we'll look for the layout-aware page class and the visual states that are defined in the markup, where you lay out how you want things to look based on the different view states. Our project is loaded in Visual Studio. I'll go to the Solution Explorer and expand the common folder where we'll find layout-aware page.cs. Again, that was added when we created a basic page and added it to our project, as opposed to the standard blank page. If we look at layout-aware page, you'll see it even talks about the fact that it supports a default view model and application view state to support visual state mapping. If we come here and look for the code that handles the various view states, we should find somewhere in here visual state switching. There we go. And in here we'll find code that handles the layout updates. There's a window size changed procedure, and there is a start layout updates and stop layout updates methods. There is a determine visual state method. These are all protected, so you can't call them. The internal code calls them. In any case, the determine visual state procedure will end up looking at code you have created in your page's markup. Let's go over here and look at the sample page. If we scroll down to the bottom, I didn't add this code. It was here. There's a visual state manager.visual state groups, and each visual state group defines multiple states. We have a visual state for full screen landscape. No markup defined there. We just use the default for that. There's a visual state for filled. Again, nothing special for that. But by default, the template for this page includes special handling for full screen portrait and snapped modes. We'll discuss carefully what happens in order to set up these various states, but I think you can get an idea by looking. It says, for example, the back button control has a style that's going to change to snapped back button style. The page title has a style that's going to be changed to snapped page header text style when we go into snap mode. When we go into full screen portrait mode, the back button has a style that's going to be changed to portrait back button style. Next time you run this application in either of those modes, check to see what happens to the back button and the title. Unfortunately, because our app doesn't have multiple pages, it's not displaying the back button, so that doesn't help any. All we can see is the snapped page header style. The page header does modify its style, and actually, I want to show that. So let's run it, and that would be only when snapped. So here's our application, and to show snap mode, we have to get back to landscape view. Here's our app, and you see where the title lines up with the text here? Let's go change it to snapped mode. There's filled mode, nothing changes. We go to snapped mode and watch that title. It gets smaller and its margin changes. That happened because we changed the style for that element. Here it is back, it's large and to the right. When it's snapped, it gets smaller and moves to the left. We'll discuss in detail how that happens, but it's all based on two things. Markup here in the page, which declaratively defines what should happen when you go into a particular visual state, and then in the code for layout-aware page, there's code that retrieves that information and handles it. You really have no reason to dig deep into this class unless you really care to. I'm guessing at this point you want to know how to make this happen in your own applications. To transition between views using XAML, you use the View State Manager to define visual state elements. The template already includes 4 visual states, and they'll be empty when you create a new page. It'll be full screen landscape, filled, full screen portrait, and snapped. By default, that section would look something like this. You'll have a Visual State Manager.Visual State Groups element, within there a single visual state group named Application View States. Don't change that name or things won't work right. Then you'll have a visual state corresponding to each of the different visual states. Notice that the visual state for full screen landscape is a closed element. They've done that because most likely you won't put anything in there. That's the view state you develop for. So you're unlikely to have to add anything there. If you do, you'll make it an open element and shove some things in there. The full screen landscape view happens when the app is full screen in landscape mode. The app is designed for this layout, so generally no changes are required. The filled state happens when a user has another app snapped to one side of the screen, taking up the small portion, and your application is taking up the larger portion of the screen. In Windows 8, using Metro style apps, you will never have more than 2 applications concurrently visible on the screen. There's no changes often required here either, and for our application, we're not going to bother changing anything for filled mode. That's enough of the screen real estate that you can see everything in our app. Snapped occurs when the app appears in the small portion of the landscape screen. The template provides different back button and title styles. We're going to relay out our controls to fit the narrow space as well. In portrait mode, our application is going to modify its layout to take advantage of the space. You may find that for your application you don't need to, but you should at least design for portrait mode, so when you're in that mode you make best use of the increased vertical layout space. Now I've got to step back and say the Visual State Manager in XAML was defined to support animations, not layout. But animations aren't necessarily the goal here. I mean, you could add animations, but none of ours will. It's kind of doubling up on an existing mechanism, and it feels somewhat clumsy and overly complex. I'm going to step back and say that this same mechanism in JavaScript is way simpler in an HTML app, and it makes more sense. This Visual State Manager is going to feel somewhat clunky. And here's an important fact. Changing the state only allows you to change property values. If you want to use this mechanism with the layout-aware page class and the Visual State Manager, the only thing you can change is a property value. You can't add or remove controls without writing explicit code. That happens when the view state changes. If you want to use just the declarative layout information, you can't add controls. The workaround is to show or hide things, or modify the style, which changes the visibility, or collapse a container control. There are lots of options, but you need to keep that in mind. When using this mechanism, you can't use it to add or subtract controls. They have to all exist when you first create your layout. To modify properties inside a single visual state, add a storyboard element. Within the storyboard, add an object animation using keyframes element. That's a discrete animation, and if you were doing animation, that would allow you to specify how long you want the animation to take. You would also specify the storyboard.targetName property, that's the name of the element you want to modify, and the storyboard.targetProperty property, which is the name of the property you want to modify. Within the object animation using keyframes element, create a discrete object keyframe element describing the time for the change and its new value. Generally, the time will be set to 0. That's why I said we aren't doing animation. With the key time set to 0, the changes occur automatically, instantly. The value you should specify indicates the new property value for the property you already specified. The element might look something like this. This says I have a visual state for the snapped view state. I have a storyboard. Within the storyboard, I have an object animation using keyframes element where I specify the target name to be a back button and the target property to be style. Within there, I've created a discrete object keyframe element specifying the key time, which is 0, and a value, which is the new value for the style property. And in this case, it's a static resource named snapped back button style. This says when you change to the snapped view state, take this animation and make it occur instantly. Instantly because the key time is 0. If you want it to occur slower, you could always put a time in there. Like I mentioned, you can't add or remove controls. You can only set properties in the markup. Instead, you could set the visibility. That's a property. You'll need to create all the markup you'll ever need and then show and hide things based on the view state. And if this just seems too clunky for you, you can always write code to create the controls at the time of the view state change. If you want to do it all declaratively, you just have to follow these rules. Let's look at an example that modifies our Hello World application to take into account different view states. Here in our application, we'll need to take a few steps before we can start modifying for various view states. First of all, I'm going to want to modify the layout of some of the controls here. And since I'll need to refer to those controls, they'll need a name. And right now, things generally don't have names. So let's go to the outer stack panel, which should be, where's our stack panel? Here it is. And let's give it a name. I'm going to call it main stack panel. We go here, set a name, call it main stack panel. And that should set the x:name attribute for that control. Let's go to the inner stack panel and set its name. And this one will be input stack panel. There we are. So it now has an x:name attribute, so we can refer to it from the markup. For the button, we'll need to name it, and I'll name it Click Me Button. And now we've named everything we need to name. Let's scroll down to the view states at the bottom of this page. There we are. Now right now, full screen landscape and filled have no markup and nothing will happen when we change to those states. If we look at snapped, it does have markup now, changing the style for the back button and the page title. I want to change other properties as well. So let me go find this markup in my little text file and get that. Here we are. And let's paste this in. Here in the snapped visual state, I'm going to add a few more object animation using keyframes elements to my storyboard. Let's clean that up. All right, now for snap, let's see what we've done. I want to take input stack panel and modify its orientation property, and I want to change it to vertical instead of horizontal. Remember, input stack panel is the one with the text box and the button. Changing it to vertical will put them one above each other. I need to take the main stack panel and change its margin so it's smaller, giving us a little more room. I also want to change the Click Me button and add a margin for it so it's separated a little bit from the text box. Let's run it and see what it looks like. So far, I haven't modified any code. I've only modified the markup. Here's our app in filled view, looks exactly the same. Let's change it to snapped view and watch what happens. The title changed as it always did, but the layout of the items within the application changed now when I went to snapped view. Let's try it again. Here we are in filled view, And you can see we have a text box and a button side by side. We've come over here now, and not only are they arranged vertically, but there's a little margin between the text box and the button. So we've effectively changed the layout for snapped view and made it look decent. We didn't change anything for landscape view, so let's go add a little more markup for that. Let me stop running this. I'll come out here, debug, stop debugging. And let's add a little bit more markup in the landscape section. Where did landscape go? Here's snapped. It's not landscape, I want its portrait mode. That's right. Portrait mode is here. Let's go get the markup we need. Let's see what it's doing. So in portrait mode, we're adding code that's going to change name input's width to make it wider all the way to 500. We're going to take the input stack panel and change its orientation to vertical. We're going to take the click me button and again add a margin. So those are the changes. We're basically just making the text box wider and pushing the click me button down. Let's try it. Here we are. Let's go to vertical mode. Watch what happens to that text box and button. As you can see, the text box got wider. The button now appears below it with a margin. Obviously, your app is going to be more complicated than this, but for this simple app, we've seen how to change the snapped and portrait modes to take best advantage of the screen real estate.